All right, we're going to start our review video for section 3.7. That's chapter 3, section 7. And as always, we identify the learning targets. The learning target in this case, there's two of them for this section. We're going to graph the rational numbers on the coordinate plane, and we're going to find the distance between 2 points on the coordinate plane. Well, we need to jump right in and get some definitions here. The first one is that term we've used a couple times, the coordinate plane. A coordinate plane is a plane in which the horizontal number line and a vertical number line intersect at their 0 points. That point where they intersect is called the origin. The origin, it'd be a value of 0, 0. 0 on the x-axis and 0 on the y-axis. The y-axis is the one that's vertical, goes up and down. The x-axis is the horizontal. That means it goes left and right. And the quadrants of a coordinate plane are the four regions into which the x and y axes separate the plane. So let's do a little drawing here. That line represents my y axis. Notice it goes up and down. This line represents my x axis. It goes left and right. Right where they cross is called the origin, and it has a value of 0, 0 is the coordinate for that plane. You can see there's four areas. This is area number 1, or quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. If you look at the values in quadrant number 1, any point that's in number 1 will always have a positive number for the x and a positive number for the y. If you look at any value that's in quadrant number 2, it will always have a negative for the value of x and a positive for the value of y. Anything that's in quadrant number 3 will have a negative for the x and a negative for the y. Anything that's in quadrant number 4 will have a positive for the x and a negative for the y. All right, let's do a few more definitions here. An ordered pair is the pair of numbers used to locate a point on the coordinate plane. The x-coordinate, or the abscissa, is the first number in an ordered pair, and it shows you how far to move to the left or the right on that x-axis. The second number, or the y-coordinate, or the ordinate, is the second number in the ordered pair, and it tells you how far to move up and down on the y-axis. Let's jump in and do an example here. You can see the point labeled A. If you look at A, I'm going to find out how many units I have to move on the x-axis. So it's 1, 2 units on the x-axis, and then 1, 2, 3 and a half on the y-axis. So it's going to be 2, 3 and 1/2 is the ordered pair for the point A. Please take a moment, pause the video, figure out what the coordinate value is, the ordered pair for this point B. When you've got that figured out, select which answer A, B, C, or D you have, and then restart the video and we'll check your work. Restarting the video now, you can go 1 unit, 2 units, 3 units, 4 units, but I'm going to the left, so it's going to be -4. And I go 1, 2, 3, 3.5 down. It's going down, so it's -3 and 1/2. So my ordered pair is -4, -3 and 1/2. And if you look at that, that's answer D. Number 6, or I'm sorry, on this one we're asked to label the point -3, 2.75. So the -3 tells me I move to the left 3 units on the x plane, 1, 2, 3 units, and then I move up positive 2.75. 1, 2, about 3/4 of the way. That's a little high. 2.75, and that's point J. Point J. Please take a moment to do this on your own. Pause the video, select your answer, A, B, C, or D, and then turn the video back on and we'll check your work. Okay, resuming the video here, we've got 1 unit, 2 units, 3.5, 3.5, and we're going in the positive direction, so that's 3.5, comma, how far do we go up? We go up 1 full unit to the A, 3.5, 1 is the ordered pair that gives us point A. And if you look at 3.5 comma 1, it's answer B out of those. Number 8 here, we're going to name that ordered pair for B. So another practice one, but here I'm going 1 unit, 2 units, maybe 2.5. So it's a negative 2 and 1/2. And then I'm going down 1, 2. So it'd be negative 2. So negative 2.5, negative 2 is the ordered pair that corresponds to B. Please do that same thing for this one, but pause the video, figure out which of those graphs show the correct answer, then restart the video, and we'll do it up here. As I look up here, I can see I've got to go to the left, negative 2.5. So I've got to go to the left, that direction on the x-axis, 1, 2. Well, this is a possibility. It's a maybe. Let's check this one. This is a 1, 2, but it's in the wrong direction, so it definitely cannot be B. If I look at this one over here, D, 1, 2, and about 1/2, so it goes in the correct distance. This is a possibility. Check the Y. The Y goes up 3.5. I don't have to check B at all because I already know it's incorrect. This one does go up to 3.5. However, it's got the wrong X values, so it cannot be that one. If I look at D here, I go 3.5, but on this one it goes down 3.5, so it cannot be D. The answer must be A, but let's check. We go back 2.5, checks out. We go up 3, 1, 2, 3.5. It does check out. A is the answer. All right, graph and label point K. It's 4, comma, negative 1.25. So the 4 is positive, so I go to the right. 4 units, 1, 2, 3, 4. And then I go down, because it's negative, 1 1/4. There's 1 1/4. Would be somewhere about there. That's point K. All right. Do this same thing on this one. Pause the video and figure out which is the correct answer, and then start the video again to check. All right, starting the video again, I've got K is 2 units to the right. It's positive, so it could be this one, 1, 2. Well, it looks like it's a little bit much there, so it's probably not A. All right, let's look at B. 1, 2 units, so B is a possibility, checking out just the X's. If I look at D, it's definitely not D because the X value would be over here somewhere and there's nothing there. This one checks out 1, 2, about 2.5, a little too far. Can't be C. I think we've narrowed it down to be letter B, but let's check it out. It would be 1, 2 units in the X direction positive and negative 2 down, 2.25 down, 2.5 down, 1, 2, and a little bit over, so it is about 2.5. So answer B is our correct answer. All right, we've got 2 ordered pairs here, and I've already graphed them for you. You can see it's 0 and negative 6, so right there, and the 0.5, so it's 1, 2, 1, 2, 3, 4, 5, and down 1. So right there, there's the 2 ordered pairs. They'd like to know the length of this line. They want to know the distance between those. I hope you can see that this is a right triangle. The distance down this side is 1, 2, 3, 4, 5. 5 units. The distance here is 1, 2, 3, 4, 5 units here. So I'm going to say that side C, it is a right triangle, side C squared is equal to A squared plus B squared, which in this case side C then would be equal to 5 squared plus 5 squared. C side C squared then is equal to 25 plus 25. All right, 25 plus 25 is 50. That's equal to C squared. I want to know what C is, not what C squared is. So I'm going to take the square root of both sides. I'm going to say C is equal to the square root of 50. The square root of 50 is going to be very close to 49. Let's see what I'm sorry, the square root of 50 will be very close to 7. But let's see on my calculator exactly what it is. It's 7.07. I'm going to round it off to 7.1. So I'm going to say the distance here is 7.1 units. 7.1 units. All right, a very similar problem, but for you to work on. Got 2 ordered pairs, one at 0 and negative 3, right there, and one at 2 and negative 6, right there. Please find the distance between the 2 of them. So pause the video, pick out your answer, and then come back and start the video again, and we'll do the work here too. If you look at this side of the triangle, it's 1 unit, 2 units, 3 units down, 1, 2 over, so it's 3 by 2. We're trying to find that side C. So we'll say C squared is equal to 3 squared plus 2 squared. C squared is equal to 9 plus 4. 9 plus 4 is equal to 13. So C is going to be equal to the square root of 13. I'm going to punch that in my calculator and see what it comes up with here. And I get 3.6. C is equal to 3.6. All right. 3.6 looks like it's answer B. Answer B. Here's a real world problem that does the same kind of math. Melissa lives in Chicago, Illinois. A unit on the grid of her map is 0.08 miles. Find the distance between McCormickville, which is at -2 and -1. So if I go over here to my graph, here's -2, and I go to -1, that looks like that's about right there, McCormickville. And Lakeshore Park, which is at 2 and 2. So if I go over here to 2, this is the 0. So I go over here to 2. And of course, when I go up to +2 is right there. What is the distance between those two? Well, that's 1 unit, 2 units, 3 units, 4 units. 1 unit, 2 units, 3 units. And I'm looking for side C, ultimately side C squared, but just side C. So C squared is equal to 4 squared plus 3 squared. C squared is equal to 16 plus 9. C squared is equal to 25. Normally I'd use a calculator, but I happen to know that the square root of 25 is 5. So this is 5 units. C is equal to 5 units. Is that how far away she lives? 5 miles? No. We have to take into account the conversion factor or the scale factor. 5 units times the conversion of 0.08. 5 times 0.08 is 0.4, in this case miles. 0.4 miles is the distance this person has to travel to go from one point to the other. Problem number 15 is very similar. Please pause the video, do the work, and then come back. All right, we're restarting the video here. Shantytown is at 2 and -1. So here's 2 and -1 is right there, Shantytown. And then the intersection of North Wabasha Avenue and East Superior Street, which they say is at -3, which would be right here, and 1, which would be right here. So they're asking for those two. They're asking for the distance from one to the other. Well, it looks like it's 1 unit, 2 units, 1 unit, 2 units, 3 units, 4 units, 5. So this is 5. This is 2. So, and I'm looking for that distance. So I'm going to say C squared. Correct that. C squared is equal to 2 squared plus 5 squared. C squared is equal to 4 plus 25. C squared is equal to 29. C then is equal to the square root. The square root C is equal to well, C is equal to the square root of 29. The square root of 29. So C would be then, that's, take the square root of 29. And that's 5.3. I'm going to call it 5.4. Rounded off to 5.4. Is that the distance? No, it's 0.08 times that. So it's 5.4 times 0.8. If I actually multiply those, I'm going to do it on my calculator here. And I get an answer of 4.3. 4.3, well, the one that's closest to 4.3 is, I'm sorry, not 4.3, but 0.43, And the answer that's closest is 4.